All right. What's up, everybody? Welcome to an exciting episode of Stats in the Basement. So let's jump right in. Let's do it. So today we're going to talk about measures of spread. So our first unit here, we've been focusing on how to summarize data. We looked at how can we summarize a data set graphically, histograms, box plots, stem plots, dot plots, and so on. Right? We looked at how can we measure the center of a data set, and then we want to talk about how we can measure the spread of a data set. You can soak in that little picture here with these histograms, right? That itself tells you a little bit about spread, right? So kind of think about why is the one on the left less, why is the one on more, and how might we measure the spread? And that's what we want to focus on. All right, so we're focused on these measures of center and spread. We keep saying that, but let's start with what do we mean when we say center? What do we mean when we say spread? So we've calculated a few measures of center. Pause the video and try to think to yourself, what measures of center have we addressed so far this year? And now that you've unpaused it, oh, that's disastrous. Just pretend that's not happening. Hopefully it'll stop eventually. There we go. For measures of center, I'll just leave that sloppiness there. Hopefully you decided, right? Measures of center, we've got mean, we've got median, right? And we've got the mode. So we know, hopefully, right, that those are measures of center. Now again, the question is, what do we mean when we say a measure of center? So a measure of center, let's get rid of this disaster here. Sorry about that. So a measure of center, right? You're really just kind of jotting down the red stuff, right? Just kind of summarize, right? So a measure of center, we're trying to represent a typical value in a data set. Or in other words, essentially, we're trying to represent a data set with one number. So if I'm trying to, like, let's say we take a quiz, or we took our unit 1 or whatever, 1A quiz on data displays. And I'm trying to represent the performance of our class with one number, trying to represent the typical performance of a student. I might use one of these measures of center to do that. Our class, we had an average of a 90. That's incredible. Great job, everybody. Right, so that tells me, right, typically students did well. Not everyone scored a 90, right, but a typical average score or maybe median score, whatever, right, is an A. So we're using one number to try to represent an entire data set. It's not going to be perfect, right? But if we want to use one number to kind of represent how much money do people in East Hartford make per household, we might use one of these measures of center. And in the next section, we'll look at which measure of center might be our best option as we discuss outliers and skew. Would it be best to use the average to represent the average income of residents of East Hartford? Or would it be better to use the median income? All right, so that's all coming. Think about that. Measures of spread. So when we're talking about the spread in a data set, spread, another word for spread, kind of a fancier, more formal word we use in statistics, is variability. So when we're looking at the spread in a data set, we're looking at how does our data vary. We're looking at, is our data clustered, right? Maybe kind of around the middle is kind of optional, but is our general, like, is our data clustered or is it more spread out? For instance, if I'm given a test, right, were all the test scores between 80 and 100 pretty clustered together? We had a pretty consistent performance. Or were the scores more spread out? Maybe they go from 40 to 100, so they vary quite a bit more. So another way to think about this is thinking about consistency, right? We're looking at the level of consistency we see in a data set, right? So spread variability, right? Is our data spread out, more clustered? How much does our data vary? So as we now focus on how to measure spread, we know one measure of spread that hopefully you can think of. We've measured the width of a data set. I suppose I didn't really want to say width because that kind of gives it away. So one measure of spread is range. I didn't think this slide was next, could you tell? Another measure of spread, standard deviation. We haven't talked much about that. That's coming. And another measure of spread we've been introduced here with box plots is interquartile range. So that's your bank. So you tell me which one's which. So for a definition here, what measure of spread am I? Max minus min measures the width of our entire data set, right? So for you, for your notes, that's kind of the definition. And then above that, what measure of spread would that be? And of course, you're telling me that is the range. One down. Next up, how about this one? This measure of spread measures the average distance each data value falls from the middle. Specifically, the average distance each data value falls from the mean. And the symbol for this is SX. So this is one we haven't discussed. So maybe by process of elimination from your bank there, range, standard deviation, IQR, you can figure out which one it is. And this is the standard deviation. So the standard deviation is measuring, on average, how far are our data values from the middle. The word deviation is actually referring to the distance from the mean, the distance from the middle. So we used Desmos the other day to calculate standard deviation, right? So that's giving us, on average, how far is stuff from the middle. So for one data set right here in blue, like if I tell you the data set, the standard deviation is 4, and for a purple data set, if I tell you this standard deviation is 20, that tells you that here, on average, the data values are pretty close, right, to the mean, sorry. So, right, if there's our mean, X bar is the symbol for mean, most of our data is pretty close, right? I'm just making these up, to this average, right? Most of the stuff is within 4 of the average. Whereas if I have a standard deviation of 20, that would suggest that data is typically pretty far from the middle, right? So it's not right here. That would be a deviation of 0. The distance from the middle is 0. But if on average, the distance from the mean is 20, that means we're going to have a lot of stuff that's far away from the middle, right? And that means we're going to have a data set that's more spread out. So higher standard deviation, more spread, lower standard deviation, less spread. To learn more about standard deviation specifically, that's a really brief, quick overview. There's another YouTube video you can watch where it gets into, it's 13 minutes. Why would I circle that? You can't click that link in YouTube, but all right, we'll link that, right? We'll share that in Google Classroom and stuff. But this gets into how standard deviation is calculated. And although we won't have to calculate it by hand in class, to see how standard deviation is calculated gives us a much, I think, deeper understanding of what it's actually measuring. All right, so that's another 13-minute video that we'll have to check out. Third measure of spread, this one we've been exposed to a little bit. So what do we got here? It measures the width of the middle 50% of our data values. Hopefully this really gives it away, Q3 minus Q1. And of course, you don't even need to pause the video because you're already thinking to yourself, I know what that is. That's the interquartile range, the IQR. So we got 3 measures of spread: range, standard deviation, IQR. Range is quick measure of spread, max minus min. IQR and standard deviation are, there's more that goes into them, a little more, I guess, detailed, not just using the max and the min. So we typically like those a little bit better for our measures of spread. And again, we'll talk about why with our outliers and skew chapter coming up next, or unit, or section, or whatever you want to call it, the next stuff. All right, so in general, right, if you have a higher number for standard deviation or a higher value of the IQR or range, right, that data is more spread out, right? So more spread out means we have larger measures of spread. And if we have a lower standard deviation, a lower range, a lower IQR, that means our data is more clustered, or in other words, less spread out. Right? So we're literally, right, like we're measuring the spread with these numbers: bigger number, more spread; smaller number, less spread. One of the main things we're going to have to do is we're going to have to examine graphical displays and try to determine which has greater variability. And specifically, this could be on the SATs, we might have to look at some data sets and try to decide which has a larger or smaller standard deviation. So I want you to think about that for a second. Looking at this top graph and this bottom one, right? This tells us here the green dot plot has a smaller standard deviation. Why is that the case? Why would we say the standard deviation for the green is smaller? And we can see the numbers right here. You can see that the standard deviation is in fact smaller for the green than the blue. Roughly, we can just look at this and say this green data set is less spread out, right? Hopefully we can see here, right, this is kind of a wider range, right? So the range would be larger for the blue graph, which suggests it's more spread, whereas here maybe this range is only from 2 to 8, right? So here we have a range of 6. In blue, we have a range of 10, right? 10 minus 0. So although that's not the standard deviation, range is another measure of spread. So we can kind of roughly use that and see that the blue, right, is more spread out. If we try to get a little more elaborate with it and this kind of get deeper into the standard deviation definition, remember, standard deviation is on average how far stuff is from the middle. So the middle here, right, that's that dotted line, that's the mean. For this, most of the data values, most of the dots are pretty close to the middle, right? I just traced over a bunch of them. Those would all, we would say, have a deviation of 0. Their distance from this green line is 0 because they're on the green line, right? These like maybe have a deviation of 1 if we're using the same scaling here, right? These dots are like 1 away from the mean. right? These were all 0 away from the mean. These, right, are still pretty close. Those are 2 away from the average, right? And this data value here is only 3 away from the average. So most of the stuff, right, the data is generally pretty close to the middle. As a result, there's a low standard deviation, right, because most of the data is close to the average. Whereas down here in blue, right, if we look at this dotted line, we've got some points in our dot plot that are pretty close, right? Those are all close to the mean, but we also have data values that are really far from the average. So these we would say have large deviations. And so since we have some stuff that's far away from the mean, right, on average, stuff is further away. These deviations of maybe 5 away from the mean, right, a little roughly, right, not exactly 5, from here to here, from 5-ish to 10, right, those are going to kind of pull up the average distance from the mean. And again, with that other standard deviation video, it's going to get a little bit more specific with those ideas and those details. I'm pretty confident, ultimately, honestly, I'm pretty confident that you guys can look at these 2 pictures and tell me the blue one's more spread out. And if the blue one's more spread out, that means it has a higher standard deviation, right? So ultimately, if you can do that, you're okay. So on that note, let's take a look at these graphs. We've got 2 histograms here. Which one of these histograms would have a smaller standard deviation? Let's think about that. Pause the video, write it down. Give yourself a sketch of these in your notes, right? They don't have to be perfect. Right over here, you can kind of do something like this just to give yourself a little brief picture, and then your other histogram, right? Just something like this, right? No, it doesn't have to be perfect. That's the same idea. And hopefully you decided that this is going to have a smaller standard deviation. Remember, SX is the symbol for standard deviation. I'm too lazy to write all those letters. So here, right, most of our data is clustered. The middle of this pretty symmetric, right, pretty bell curve-ish graph. The middle of this distribution, the mean, right? We're just eyeballing it right now. I can't calculate the average. Maybe the middle's around here, right? So the tallest bins, the largest amounts of data, the highest frequencies are all pretty close to the middle. So these things are all going to have smaller deviations, right? Most of your data, that big cluster of data, is pretty close to the middle. Whereas over here, right, the middle of this graph is somewhere around here. And for this histogram, our largest frequencies, right? We have a lot of data on the outsides here. And so these have large deviations. These are further from the middle. So in general, if your data is pretty clustered in the middle, like we see in purple here, that's always going to have a lower standard deviation. Whereas if you have a histogram or a dot plot or whatever, stem plot, any graph, well, not any, just those 3. If you have one of those 3 graphs and more of your data is on the outsides, that's going to have a larger standard deviation. What do you think about this dot plot? This one's kind of hard to sketch in your notes, so maybe we'll think about this. Don't. Oh wait, I might give you these slides. But anyways, which would have a larger standard deviation here? Now again, remember standard deviation's a measure of spread. So whichever one is a larger standard deviation is the dot plot that's more spread out, right? Because standard deviation is a measure of spread. Larger standard deviation means larger or more spread. So really, I'm pretty sure if I reword it that way, I think you guys all know which one's more spread out. I'm not too worried about that. I'm sure we all realize, confident about this, faith in you, that this is more spread out. And again, we can kind of roughly use the range. That's not a perfect method, but it kind of works, right? Here, the data values go from whatever, that purple line to that purple line with no numbers. Here, right, that's a wider interval, right? This squiggly distance is longer than this line. Beyond that, here, we've got a lot of data clustered in the middle, and anytime we have lots of data that's clustered in the middle, that's always going to lead to a lower standard deviation, right? So like a bell curve, even if there's the same range, like I mentioned, the range thing doesn't always work, because even if I try to line these up, this is going to have a smaller standard deviation, right? Even though the range is about the same. So I'm doing this on purpose, right? Because I don't want us to think that the range is a foolproof method. Is it foolproof? Who cares? This is going to have a smaller standard deviation than this uniform distribution because it's more clustered in the center. The highest frequencies are in the middle, whereas here the frequencies are kind of all evenly spread out, right? That's what the definition of roughly uniform is. More clustered in the middle, lower standard deviation. 2 more. You got these. Oh, I lied, 3 more. Another one. Which one has the largest standard deviation here? A little tougher because we got 4 to choose from, so pause the video. What's the largest standard deviation? And of course, you were thinking to yourself, largest standard deviation is the one that is the most spread out. And so I'm sure you guys all told me this, right? These are all pretty concentrated, pretty condensed, right? These are all similar in the fact that they have a lot of stuff in the middle, right? Their highest bins are concentrated in the middle. And aside from that, right, they're all pretty tightly packed, right? Those are pretty narrow histograms with really high peaks in the middle, whereas this one is much more spread out, right? We've got lower frequencies in the middle. We've got, stuff that's much further away from the middle for this distribution than we do for either of these 3, A, B, or D, I guess. So that's kind of the idea with standard deviation, right? It's not about calculation. We can use the Desmos calculator for that. It's about 1, higher standard deviation means more spread, and then 2, being able to translate that to these kind of graphical examples. All right, 2 more, this time for real. So which company has the largest IQR, and how do you know? Pause it up, do it. All right, now for the how do you know in the largest IQR? Now, of course, you could go through, right? And IQR is Q3 minus Q1. So we could, if we had this paper in front of us or, a better graph where you could actually read the numbers, right? We could go through and we could actually subtract Q3 minus Q1 for each box plot to make our decision. Well, remember that if we're subtracting Q1 from Q3, Q3 minus Q1, right? We're just finding the distance between these values. So the IQR, right, when we look visually, the IQR is just the width of the box, right? It's the distance from Q1 to Q3. So to decide the largest IQR, we don't need to do any of that stuff with numbers. We can just look at the picture. Largest IQR, and for the how do you know, the largest IQR is going to be company B here because it has the widest box or the longest box, however you want to say it. That's it. Like, sure, again, you could subtract the numbers and get all the numbers and compare, right? That works too. That takes a little longer, right? Now that we know that, like if I show you this, you instantly know which one has the largest IQR, I think. Let's find out. Last slide. Which sample here, sample 1, 2, 3, or 4, which sample has the smallest the smallest IQR? That means it's got the narrowest, is that a word? I don't know. It's got the narrowest box. Boom. Sample 1 has the smallest IQR. Seemed kind of unnecessary to write that. All right, I think that's it. I think we're done. It's time for me to get out of here because, I'm pretty hot, dog.